Hey everyone, welcome back. So we are solving problems based on binary search. So today we are going to solve one more problem. Find first and last position of element in sorted array. It is a medium problem from the Leetcode. So in this problem you have given an array which is in the sorted order and also given a target. Now you have to find the first position of the target and the last position of the target. Okay, so the first position is 3 and the last position is 4. So you have to written 3 and 4 and position should be like this, means first should be less than last, it should not cross. Okay, so let's take another example. So we have same array but this time we have target of 6. Now in this case we don't have our 6 value in the array, so this time we will return -1. Okay, and let's take another examples. Target 3. Now this time our first element is 3 and the last element also the 3. So we can solve this problem using a brute force, right? You just have to run a loop from here and here and you have to find first and last position of the target, but make sure that your first should be less than last, right? Because if it crossed, that means it wasn't able to find your first and last position. But the time complexity will be big of n, right? Because we are running loops, or you can say we are linear searching in the array, so it will take big of n. But the question asked us to solve this problem in the log n time complexity. So if it is asking for the log n time complexity and also we have to search the value, so in this case we can use our binary search, right? So let's take this example again. We have target here 8, right? So in binary search we already seen what is lower and upper bound. So in lower bound it finds you the smallest index which is greater than equals to the target, and upper bound finds you the value which is smallest index which is greater than target. If you look at it, if you do a upper bound with the target 8, it will return the index of this value, and if you do a upper bound which is greater than target, then greater than target is 10, right? So it will return me the position of this index. So you just have to do a minus minus, right? So from here you will get the first position, from here you will get the last position. You just have to reduce by one index. Okay, so in this way you will be able to get your first and last position using lower bound and upper bound. So remember this, lower bound is finding you the smallest index such that your value is greater than equals to the target, here greater than x or greater than target. Okay, so you just have to reduce this position by 1, so you will be end up at this position. So let's write a code. So given an array integer num sorted in non-decreasing order, means it is in increasing order, find the starting and ending position of given target. Okay, so we have given a target and you have to find starting and ending position of that target. Okay, if target is not found in the array, return -1. So in this case target 6 is not present, so we will return -1. You must write algorithm with big of log n and time complexity. So we will use lower bound and upper bound. And also here you can see third example, the array is empty, so value is not available. So in this case also we will return -1, right? So let's write a code. Let's first declare our size of array. Let's handle the case where we don't have a single value, right? If we don't have a value in the array, so we won't be able to find any first and last position, so we will just return -1. Now let's declare first, which is initially -1, then last, which is also -1, then we will declare low and high. Now we have to find two positions, first and last. So let's first find the first position. So low less than equals to high, int mid equals to low plus high by 2. So if we are finding the first position, then we have to apply lower bound right? So nums of mid greater than equals to target. So if it is greater than equals to the target, we can say it might be my position. So we will update and we will move to the left side, right? Because we are trying to find smallest index. Else we will move to the right. Now this is the code for the lower bound. Before moving to the upper bound or finding the last position, we should check if my first is not equals to the -1. Means if it is equals to the -1, then we will return here -1. Because if it is not able to find even a first position, that means that value is not available in the array. So we don't have to move to the second step where we have to find the last position, right? If first is not available, then there is no chance that second is also available. So we will return -1 from here. Else let me copy paste it here. Also let's update our low and high again, right? We will reset this value again because we are going to use same values. Now for the upper bound, we just have to look for the greater value, and here we will check for the last. Now we were able to find first and last position. Now we just have to check one more condition. Our first should be less than equals to the last, right? Our first and last should not cross. Now there is one more changes we have to make, right? Which is last minus, right? Because in upper bound it is finding the value which is greater than the target, but we have to go to the target value itself. So we will return at one index less. So let's run it. So our initial test case got passed, so let's submit it. So for the nums value, it should return 0 not minus. So our code got accepted. So the problem was here. For the last, we were assigning the -1, but when we are trying to find the value greater than target, it will point next to the target, right? But in the case where we have single value, right, so it will point to the next value of the one which is outside the array, right? So if it is outside the array, then we should keep the last as n. So our n is 1, so the upper bound will return me the n which is 1. Now we just have to reduce by one index, so it will point to the 0 index. So the first is -1 and the last is n, okay? Because in some cases our last will be end up outside the array, so in that case we will just directly assign n instead of -1. Okay, so this is our whole code for this problem. So we declared first and last. First we find the lower bound. If target is not available, we return here -1. Else we will move to the finding the last position and we will return our answer. So this time we have to use same code again and again. So you can create a function and try to merge this code in a single function. Okay, now there is a simplest way to solve this problem, right? In this case we have written a code for lower bound and upper bound, but there is a inbuilt function in C++. Using this we can easily find our lower bound and upper bound. So let's see how we can do it. So let's remove this. Also let's remove this. Okay, let's first find the first position. So we will use lower bound, and we are using lower bound in the array. So we will write nums.begin, nums.end, comma target. So we are using lower bound function and we are passing our array and as well as the target. Okay, then for the last position we have to use upper bound. So we will here write upper bound. Okay, let's try to run it. Okay, so there is one more problem. The lower bound is a pointer which is pointing to the memory address of that index. So we have to find the index. So we will minus our first index from the, so it will return me the position. Similarly for the last, it should be nums.begin, not end. So our code got accepted. We don't have to write whole code for lower bound and upper bound. We can use inbuilt function. So let's see how this is working. Okay, so let me write first. Okay, so let's only try to print our first. Okay, so what it is holding. So let's run it. Okay, so I cannot run it here. Now here you can see this lower bound function is returning me the pointer. Pointer basically means memory address. So if you want to access the value at that memory address, you have to use star, right? Because that's how the pointers works. So it is returning me the 8. Now I want position, not the value, but this lower bound will return me the pointer. So we cannot print the pointer because it is giving me the error. So what happens if I have a pointer from this position and I am subtracting pointer from this position? So this position minus this position pointer, it will return me the difference. So the difference will be the position of that value itself. So let's print it. So here you can see it is returning me the position 3. So there is some memory address. If you do a subtraction, it will give me the difference between both the memory address, which will basically a position at that index. Okay, so whenever you want to find the index, you just use lower bound, then subtract first memory address from the lower bound. Similarly for this last position. Okay, so this is our whole code, and the time complexity is log n because we are using binary search. Okay, so this is our whole solution for this problem. That's it for today. Until then, thank you everyone. Have a nice day.